Hello guys, good evening everyone. Good evening guys, good evening. Right, welcome to the physics session. And it seems Preeti has asked a question. Preeti, are you there, ma? Drop a message in the chat box, in the live chat. Ma. Okay, anyhow, just I will explain this. You can go through once you come to the link. Okay. Question number 50. Let me see. Question number in collisions. Collisions level 2, exercise 1. Level 2, exercise 1. Yeah. Level 2, exercise 1. You have asked the question 50. Question 50. So, what is this? Let me give you briefly. The question is a sphere of mass m moving with constant velocity u collides with another stationary sphere of same mass. If E is coefficient of restitution, the ratio of final velocities of the first and second sphere is ratio of final velocities of the first and second sphere is right. Let's see. Yes, no, good evening, Priti. Let us see that question number 15, question number 50, page number 48, 48. Second spheres. Yeah. How to take this ratio? So just we'll see briefly. Once again, a sphere of mass m moving with constant velocity u collides with another stationary sphere of same mass. And if E is coefficient of restitution, if E is coefficient of restitution, the ratio of final velocities of the first and second spheres. So simply you can calculate the final velocities of the two spheres after collision, then you can try to find the ratio of this. How can you let's try to you have to remember the expressions for final velocities of the two bodies. It is mentioned that a sphere of mass m moving with the constant velocity u. There is a sphere of mass m moving with the constant velocity u. It is initial velocity u1 is equal to u. There is another which collides with another stationary sphere of same mass. There is another sphere of same mass, which is whose initial velocity. This is first one. This is second one. Okay, m1 is equal to m, m2 is also equal to m. So this is at rest. u2 is equal to 0. Same mass. Then the question is, if E is coefficient of restitution, E is coefficient of restitution, the ratio of final velocities. So after collision, let us say this is before collision. After collision, then we undergo collision. After collision, the first body, because of the same mass, it may comes to rest. So V1 will be maybe equal to 0, but V2 will be, what will be the V2 is the question. What will be V2 is the question, right? So how can you understand this is, can you say the velocity here, if it is perfectly elastic, it is okay. They will interchanges. But in this case, if the coefficient of restitution is mentioned and nothing else is mentioned, right? In such cases, you have to consider this in a different way. So how to consider that? Let us try to understand. We know that coefficient of restitution is equal to, it is the ratio between relative velocity of separation by relative velocity of approach, right? Relative velocity of separation by relative velocity of approach, that is u1 minus u2. u1 minus u2, as u1 is greater, of course. Then how can you, uh, one second, here you are asked to find the ratio between the relative, sorry, the coefficient of restitution. E is equal to what in terms of V is coefficient of restitution, ratio of final velocities of the first and second bodies. First and second bodies. So how can you deal this is, can we say the total here, it doesn't mean that after collision this final velocity it will comes to rest and it will start moving, so its initial velocity may be 0, but it is not mentioned that it is perfectly elastic. So what to understand is, what you have to understand is, total momentum of the collision before collision, if whatever may be the collision, whether it is elastic or inelastic, momentum should conserve always. Momentum should conserve always. So from law of conservation of momentum, from law of conservation of momentum, it's a total momentum, total initial momentum equal to total final momentum. So total initial momentum is equal to total final momentum, right? So total initial momentum is, mu plus its velocity is 0, so m into u is equal to final momentum is, if its velocity is v1, its velocity is v2, mv1 plus mv2, m is same, so you can take it as m into v1 plus v2, so gets cancelled, so you can write it as u is equal to v1. What is the question? You should know what is, you should find what is v1, what is v2, then you can find out. So to find v1, v2, let us add them, because it is v2 minus v1, this is v2 plus v1, let us add them, then we will get one each quantities. So we can say that 1 implies v2 minus v1 is equal to eu, and 2 implies, what is this, v2 plus v1 is equal to u, and if you add them, what will you get? This v1 gets cancelled, 2v2 is equal to eu plus u, or you can write it as, if you take u common, then you will get 1 plus e into u. This is 2v2, and hence v2 is equal to u into 1 plus e by 2. This is v2. This is v2. Find out v1 from any of these equations. Let us say from equation 1. So let us say this is equation 3. Then equation 1 implies, what is that? v2 minus v1 is equal to v2 minus v1 is equal to eu. From this, v1 is equal to, if you bring it here, then v1 is equal to v2 minus eu is equal to, v2 is u plus eu divided by 2 minus eu. So you can simplify this as u plus eu minus 2eu divided by 2. So u plus eu minus 2eu gives u minus eu. So this becomes 1 minus eu divided by 2. So therefore you will get v1 is equal to 1 minus EU or UE, whatever it is, by 2. This is V1. Let's consider this as equation number 4. We want ratio between V1 and V2. So therefore, you can write V1 by V2 is equal to, this implies V1 by V2 is equal to, V1 is 1 minus EU divided by 2. V2 is, directly can write U plus EU divided by 2. 2 gets cancelled. So what will you get? Is it EU only? One second, guys. Here, wait. I think this is U plus EU here. This is not 1 minus EU. Here U, this thing, the U minus U. So it is U here. It is U. It is U. Okay, this is U. So we'll get U is common in both terms here and there. Then you can write, if you take it as U out, 1 minus U into 1 plus E. So U gets cancelled. So we'll get 1 minus E by 1 plus E. That's it. Therefore V1 by V2 is equal to 1 minus E by 1 plus E. 1 minus E by 1 plus E. Is there any such option? Right, 1 minus E by 1 plus E. That's option 2. That's it. That's the correct one. I hope it's clear, guys. Next, let us see question number 48. Question number 48 also. Question number 48. So what is given here and what you are asked to find? It is given that a ball is dropped from a height h. Question number 48, page number 48. Question number 48, page number 48. Right now, see here, the question is, a ball is dropped from height h onto a floor of coefficient of restitution E. The total distance covered by the ball just before second hit or second collision is, it is one of the previous year's engineering exam. Okay, it is in 2008 in IIT mains this question is asked. Okay, so what is this? The 50th question what we have discussed was, it is asked in medical exam APM 2007. Okay, this is a NEET exam. It was asked in 2007. So this is, so this kind of questions will come in exams, guys. That is what I would like to mention here. So this kind of questions will come in exams. So try to understand what kind of questions are coming in exams and how to understand them and how to deal with them. So it is mentioned that a ball is dropped from a height h. There is a ball of mass m. It is dropped from height h onto a floor. It is dropped means initial velocity is 0. It is dropped from height h onto a floor. This floor is having coefficient of restitution E. The total distance covered by the ball just before the second hit, it comes what you're asked to find the total distance covered by the ball just before second hit. Before first hit, it travels distance of h. Before first hit, then after the first hit, it raises up and reaches to some height h1. Then again comes down and travels a height of distance of h1 again, and then hits the floor second time. So before second hit, It travels a distance of h, then again h1 plus h1 to h1, h plus to h1 distance it will travel. So the total distance traveled, write down clearly, everyone here. The total distance traveled, the total distance traveled, the total distance traveled before, the total distance traveled before second collision or second hit, or second strike or second collision, second hit or collision is d is equal to before first hit h, then before second hit h1 plus h1 to h1, so h plus 2h1, h plus 2h1. But in the options they have mentioned in terms of h and e also. So for that purpose let us try to express this h1 in terms of h. For this purpose we have to remember that what is that, the general relation you can remember. What is that, the distance traveled in, what is that, the height of the body after nth hit or nth collision is given by, because hn is equal to e power 2n into h. If you remember this, it will be a little simple. Otherwise, you have to just use the conventional procedure and you have to find out. So after first hit, then it will be e square h, e square h. Is it clear? So then you can write it as h plus 2 into e square h. So here if you take the h out, you can write it as h into 1 plus 2 e square, right? Right, that's it. That this will be the total distance traveled. If the height is given, the numerical value of height is given. If it is a ball is a body or a ball is dropped from a height of some 10 meters or 4 meters, something like that, or 9 meters, something like that, then you have to substitute the value and you will get some different value, different place, some numerical value you get. That's it. Okay, this is a general relation for it. The distance traveled before second hit is h into 1 plus 2 square. Note it down. Is it clear, guys? If you see here, question number 47, they have asked what is the time taken before the second hit. In the 48th question, it is asked about what is the total distance traveled before second hit. Okay, so to understand this, you should remember this relation: total distance traveled. How to find especially total distance traveled before it stops bouncing is this one, or in every collision. How to find the total distance traveled is I have discussed clearly. These steps you have to remember, and similarly the time taken before it stops bouncing, total time taken before it stops bouncing is this much, and after every collision how much time it takes to uh, it takes before the another collision or another bounce will be understood with the help of these relations: t plus 2t1 plus 2t2 etc. This can be further expressed in terms of heights, okay, depending on this. And of course this what is that, sum of infinite series also you should remember, infinite sum series. This formula also you should remember, guys. Right, guys, now let us try to work out few more questions. So even try some questions from level 1. I hope this level 2 questions I will work out every question for you guys. Now you guys try from level 1. Level 1 you try some questions now. Level 1 for question number 49, question number 50, question number 49, question number 50. Question number 50 is a direct question, I think, right? What is that? A ball is dropped from a height of 3 meters. If coefficient of restitution between the surface and the ball is 0.5, then total distance covered by the ball before it comes to rest is. Here we have derived the expression here. Here the numerical values are given. Just directly you have to substitute. So based on this, see here this everyone. Question number 50, page number 43. You should remember this. Total distance before traveled before it stop bouncing is h into 1 plus c square by 1 minus c square. You remember these relations. And the time is square root of 2h by g into 1 plus c by 1 minus c. You have to remember this. You have to remember these relations, guys. Now, see question number 50, page number 40, 43. So what is given here? A ball is dropped from a height of h is equal to 3 meters. If coefficient of restitution between surface and the ball is E is equal to 0.5, then the total distance covered by the ball before it comes to rest. Total distance traveled before it comes to rest means before it stops bouncing. What is the total distance traveled before it stops bouncing? Yes, h into 1 plus e square by 1 minus e square, or 1 minus e square by 1 plus e square. Yes, h is h into 1 plus c square by 1 minus c square. Total distance traveled before it stops bouncing is h into 1 plus c square by 1 minus c square. H into 1 plus c square by 1 minus c square. So here h is given and e is given, direct substitution only. So what will you get? H is 3 into 1 plus e square. E is 0.5. 0.5 square is 0.25. So 1 plus 0.25 divided by 1 minus 0.25. So what is this? Is equal to 3 into 1 plus 0.25 is 1.25, and 1 minus 0.25 is 0.75. 0.75. This further can be expressed as d is equal to 3 into, if you multiply both numerator and denominator with 100 here, it becomes 125 by 75. So it will becomes 125 by 75. So how can you simplify this further? 25 threes, 25 fives. So here 3 gets cancelled, we'll get 5. Therefore, d is equal to 5 meters. It travels 5 meter distance. That's it. So option 3 is the right one. Go through it. So before it stops bouncing, before it comes to rest or stops bouncing, it travels a distance of 5 meters. It travels a distance of 5 meters. Right, next. So question number 51. Question number 51. You can try question number 51. What is given here? A glass sphere of mass, a glass sphere of mass 5 milligram, 5 milligram falls from a height of 3 meters, falls from a height of 3 meters onto a horizontal surface. If the coefficient of restitution is, if the coefficient of restitution E is equal to 0.5, 0.5, then after the impact, the sphere will rise to a height of, that means, say this is a surface, let's say this is a surface, there is a glass sphere of mass m which is at a height of h. After falling to this height, after here the surface is the surface of this surface is having coefficient of restitution. So after impact, again it will bounces back and raises to a height of h1. So what is the height raised by this? If the coefficient of restitution of the surface is the e, is the question. We know already there is a general relation. The height raised after nth impact. We are asked to find what is the height raised after the first impact h1. So but we know that height raised after nth impact is e power 2n into h. After first impact, h1 is equal to e power 2 into h. It is equal to e is 0.5 square into h is 3. Of course, even the mass is given, mass is nothing to do here. Okay, 0.5 square is 0.25. 0.25 into 3. So what is this? Actually, you can write it as 25 into 10 power minus 2. 25 into 3 is 75. Right? S into 10 power minus 2 is again 0.75. H is equal to 0.75 meters. So it travels to a height of h1 is equal to 0.75 meters after first bounce. If its coefficient of restitution is 0.5, that is the meaning of it. Only 0.75 meters. If it has fallen from 3 meters height, after first impact it will travel say not even 1 meter, 0.75 meter, just will rise. That is the meaning of it. That is the meaning of it. So it will rise to a height of 0.75 meter after first impact. Note it down. Next, you can see question number 52. Question number 52. So this is a direct formula. Yes, this is a direct formula. Question number 52 is a direct formula. Right. See here, question number 52. What is given here is a particle falls from a height h upon a fixed horizontal plane. A particle, let us say of mass m, falls from height h. Falls means is dropped or falls. Initial velocity 0 from height h upon a fixed surface, upon a fixed plane, horizontal plane, and rebounds, and rebounds, and rebounds. If E is the coefficient of restitution, then total distance traveled by this before it comes to rest. Total distance traveled before it comes. After first impact, it will travel to a height of h1 and comes back again, traveling through same height. It comes back and then undergoes second collision. After this, again it will moves up with here with velocity v1, here with velocity v2, like that. It will go to next height h2. Like this, it before it come number of collisions, infinite number of collisions or impacts it undergoes, and then it comes to rest. So the total distance traveled is equal to, this is already derived formula. It is a derived formula, right? It is equal to h plus 2h1 plus 2h2 plus so on, and we have derived this already. So this gives you what? D is equal to h into 1 plus e square by 1 minus e square. If you have any confusion, guys, go through this once again. This is very important. This is very important. These relations, the total distance traveled before it stops and total time taken before it stops. This kind of relations are very important, guys. Go through this. Right. These are all from page number 43. These are all from page number 43. This is from this. This also from this. 50. Okay, from 43 page 49 question have not worked. You can try this next. Question number 49. Question number 49. Question number 49. Same 43rd page. So what is given here and what you are asked to find? It is given that a ball falls from a height of 10 meters onto a horizontal plane. A ball, right? Say a ball falls from a height h, which is equal to, a ball falls from a height of h is equal to 10 meter onto a horizontal plane, if the coefficient of restitution E is equal to 0.4, then the velocity with which it rebounds from the plane after second collision, velocity with which it first it obtains maximum speed here before hitting. Then after hitting, it will bounces up with some after first collision, it bounces up with velocity v1, and it goes to some height h1. Then again travels back the same distance and hits second time, then it raises up with the velocity v2, and it goes to some height h2. So here the question is, then the velocity with which it rebounds from the plane after second collision, that is, what is the velocity with which it rebounds back after second collision, v2 is equal to what is the question. So you have to recollect back here the concept of what is that velocity after nth collisions, velocity of nth collisions, and height after nth collision, or velocity of nth collision. We have discussed these points also. We have to remember this. Total distance traveled before it stops, total time taken to before it stops, before it stops. These are different. And here next, velocity after nth collision, height after nth collision. These 2 points also you have to remember. Velocity after nth collision is e power n into what? E power n into v. What is that v? Velocity here before first collision. Before first collision. Similarly, height after nth collision is hn is equal to e power 2n into h. You have to remember this here. Okay. So after second collision, v2 is equal to e power 2 into v. Here e is 0.4 square into v. What is v? Into v. What is v? Here find out. Here v is equal to velocity obtained before it striking the ground. Here this velocity obtained when coming from here to here after passing through height of h is v, where v is equal to square root of 2g h. It is equal to square root of 2 into g. 10 into h is also 10. Square root of 200. V is equal to square root of 200, or you can say root 2 into 10 square. It comes out and it becomes 10 root 2. This is equal to 10 into root 2 can be expressed as 1.4, 14, or 1 simply 1.4. This gives 1.4 into 10 is 14. Or if you write it as 1.414, it will be 14.14. Okay. So if you substitute this here, you can write here where v is this. This is equal to 0.4 square is 4 square is 16, 0.4 square is 0.16 into v is 14.14. What is this? Simplify yourself. Yes. What is this? 0.16 into 14.14 is equal to 2.26 is equal to 2.26 2.26 2.26 approximately. If you take it as only 1.4 instead of 1.414, it may get little lesser. What is this? Here if you take it as 0.16 into 14, this 14, then 2.24 you get. So instead of this here the root value, instead of taking 1.414, if you take only 1.4, you get 2.24. Here the options are based on that one. This decimals you have to just take approximately. Now you can take this as approximately 2.24. So therefore velocity after second bounce is 2.24 meter per second. That's it. That's it. Even if you take this as 14.14 also, you get 2.26. But if you see the options, 2.2 option kind of values are, what is the first one? 2.24, 5.6, 2.8 is there, not 2.2. So I have to take up obviously 2.24 or 2.26 are approximately same nearby values. You can take that one. That's it. Yes, guys, and level 1 exercise 1 questions you guys practice. You guys practice. In the next session, we will discuss a few more additional points, a few more applications related to this, and we will try to work out few more questions based on this only in the next session. I think you tomorrow is a holiday for you guys, right? So enjoy your holiday. Happy Republic Day to everyone in advance. Wish you happy the great Indian Republic Day. Enjoy everyone. Take care. Bye bye. I'm winding the session now. Take care.